So first, today, what are we going to do? Moment of inertia, torque, angular momentum, and last topic, pure rolling. These are the four topics which we are going to discuss. So we'll cover rotational motion today. Basically, we'll finish it. Let's discuss the first question. Also, read the first problem. So moment of inertia of a disk. Basically, how many disks are there? Two disks, right? X and Y. The radius of the first disk is R, thickness T. Second disk, radius 4R, and what is the thickness? T by 4. So we need to compare their moment of inertia. That is the question. So what is the formula for moment of inertia of a disk about its center of mass? Mr square by 2. I hope that you guys revised what I asked. If you've still not seen the lectures, I've shared the lectures in the group for rotational motion. See it. I've discussed all the things in detail there. So moment of inertia of the disk X. What is the formula? Mr square by 2. About its center of mass. So how will you find the mass? They are made of iron plate and thickness P. Second one is also made up of what? Iron. Both are made up of iron. Will the density same or different? Same. The substance is same, density will be same. What is the formula for mass? Density into volume. What is volume? Area of cross section into thickness. So what is the area of cross section of a disk? What will you write the area as? What should we write area as? If it is a disk, what is so pi r square? What is the radius? R. So pi r square into thickness is T. Any problem? This is a mass of X. Now similarly, mass of Y. Density will be same because it is also made up of iron. So density into volume. Volume is area of cross section into thickness. So what will be area? If you see radius is 4r. Pi into 4r ka square. So pi into 4r square. And what is thickness? P by 4. Any problem? All clear? Substitute. I think now you can aram se solve it. So mass is density pi r square into T into r square by 2. This will be mass. What is mass? This pi should be outside. So this into 4r square will be 16r square into how much? T by 4. So this much is the mass multiplied by r square. What is r for y? 4r. So it will be what? 4r square divided by. So solve both, check what is the relation. So this is the mass, this is the radius ka square, mr square by 2. Let's solve it. So rho pi r to the power 4 into t. Okay, I took this outside divided by 2. If you see the constant, just count the constant. This is 16. 4 4s are 16. 16 into 16 by 4. 16 into 16 by 4. 16 into 16 by 4. What is 16 into 16 by 4? So this will be 4 times. So any option is there for 64 times? Answer is option D. Answer is option D. You can see that this 64 is extra. This term is exactly same as this term. So which one is the extra term? 64. So Iy is 64 times of Ix. Okay, so this one was a good problem. Nothing difficult, but yes, how to write the volume was a different thing here. That volume will be area of cross section into thickness. Done. Okay. We'll move to the next one. Mark this question as important. Okay, there is nothing difficult in this. That's why these kind of questions are more common. Means you just need to analyze that how to write the volume, and you need to know what is the moment of inertia. Moment of inertia should be on your fingertips. That is the reason I've sent the lectures so that you watch it and come. I sent it 2 days ago. Done. Remove it. Next problem. Second question. Moment of inertia of a system about an axis passing through A and parallel to BD. So draw the figure quickly. All of you draw the figure. Draw the figure. The 4-point masses. So we have 4 masses. This is M, 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 and M. A, B, C, D. So this is A, this is B, this is C, and this is D. First join BD. You need to find the moment of inertia about which axis, which is passing through A and parallel to BD. So passing through A and parallel to BD. Correct? So this is your axis of rotation. You want this whole system to rotate about this line. So tell me that this particle is present on the axis of rotation itself. So what will be R for this? 0. Moment of inertia basic formula is what? mr square. This particle is present on the axis of rotation itself. R is 0. So what will be the moment of inertia of this particle? 0. It means that you need to bother about which particles? B, C, and D. Clear? So moment of inertia, I will name this. I will name this as anything AA dash. So moment of inertia about AA dash will be equal to due to B plus due to C plus due to D. Due to A, it will be 0. I explain the reason why. Because the particle is present on the axis of rotation itself. So the perpendicular distance R will be 0. Moment of inertia will be 0. Now, so let's solve it. So what is the moment of inertia of a particle? mr square, where R is the perpendicular distance from the axis of rotation. So what is the perpendicular distance of C from the axis of rotation? This is a perpendicular distance. So this perpendicular distance is same as the diagonal of the square. So what is the length of the diagonal of the square? Root 2 times the side. Root 2 times the side. So what is the side given? L. So due to C, I am writing due to C. It will be M into root 2L whole square. Any problem? Now due to D, join D to the axis of rotation. This is the perpendicular distance. If you see that this distance is basically how much? Half of the diagonal. See it? Half of the diagonal. Same thing will be applicable for what? B. This distance will be half of the diagonal. So can I do this 2 times directly? So for D and B, I will write plus 2 times of mass into what is the distance? Half of the diagonal. So diagonal is root 2L. What is half of that? L by root 2. Half will be L by root 2. So L by root 2 whole square. Diagonal is root 2L. What is half of root 2L? To solve it, this will be 2m L square plus 2m L square by 2. What is the answer? 3m L square. Nice problem. Okay. Copy this quickly. But when you see it overall now, after seeing the solution, see, before seeing the solution, it may be difficult. After seeing the solution, you will say, I'm doing basic maths. So these kind of question, like I was telling that whatever question you are discussing in the class, that you have to solve must. Iske baad, whatever you are practicing previous year question, do it. But these questions you have to solve. It's a very nice problem. It's not directly, but once you draw the figure, everything will be visible in front of you. Done. Write a bit fast. We have to finish this today. Class will be till 3:30. That's why I've extended 30 minutes. This is a difficult chapter. After this, I will first try to finish all difficult chapter. What is a difficult chapter after this in physics? Fluid mechanics and SHM. These 2 chapters I will finish first after this. Okay. Thermodynamics and thermal part is easy. First we will discuss all the difficult chapters. Okay, should we move ahead? Any one of you who needs my lecture of thermal physics can let me know. Thermal physics means mechanical property, thermal property, KTG, and thermodynamics. If you need the lectures, you can ping me. I'll put all the lectures on the WhatsApp group or send you. Okay. Draw the figure quickly. Lamina means thin plate. Lamina means plate. Students who don't know the meaning of lamina, lamina means a thin plate, means a two-dimensional plate. So we have a square cup, a square shaped plate whose center is O. You need to compare the moment of inertia about two axes of rotation. So axis AC and axis EF. Okay, draw on the figure. Okay. There's no need to calculate anything. See on the board. You can tell the answer within 5-10 seconds. Listen to me. All of you listen to me. There's nothing to calculate in this. We will solve it by observation. You can do the calculation, but in MCQ, don't waste time in solving. By analytical method, let's try to solve. If you have a square, if you have a square, I want to find the moment of inertia about the axis which is passing through the center of the square and perpendicular to it. Are you guys seeing this? This is the axis of rotation. Is this axis of rotation perpendicular to the square or not? Yes. So the moment of inertia of the square or square plate about the axis which is perpendicular to its plane passing through its center of mass, perpendicular to the plane and passing through the center of mass is m a square by 6. What is a? A is the side of the square. Okay? Is the statement clear? Now, instead of square, if I take a rectangle, will both the dimension be same or different? Different. Correct? Length and breadth. So there what happens, it is ma square. See this carefully. Ma square by 12 plus mb square by 12. This is for length, this is for breadth. This is for rectangle. In square, what will happen? A and B will be same. So when you add them, what will you get? Ma square by 6. Okay. So for rectangle, this is the moment of inertia about an axis passing through its center and perpendicular to the plane. For square, A and B will be same. The moment you add, you get this thing. You make a note of this. If you have understood this thing, it will take 2 seconds to answer this. Okay. Now see here. So this is the axis of rotation coming towards you. If I join like this, first diagonal and second diagonal, okay, and I'm assuming that this is present in XY plane. Which plane? XY. So axis of rotation is which plane? Z. Z. So there is a theorem. You guys remember that perpendicular axis theorem? Ix plus Iy is equal to Iz. Okay. Iz I already know. How much is it? Ma square by 6. Now just tell me that either this diagonal or this diagonal, both are doing the same thing or not? They are dividing the square into two equal parts. So the moment of inertia about either this diagonal or this diagonal will be same or different? Use common sense. Same. So can I say that 2 times of diagonal? So what diagonal? You can name it A, B, C, D. So 2 times of moment of inertia about AC will be equal to what? Ma square by 6. What will be the moment of inertia about diagonal? Ma square by 12. Clear? Same thing if I do for the side, not diagonal, this thing, this and this. Okay? Just observe this line. If you see the moment of inertia about this line, two equal parts, left, right. Now forget about that line and see this axis. Again, same thing or not? Two equal parts. Can I say the moment of inertia about this line and this line will be equal? Because the square is a symmetrical figure. Square is a symmetrical figure. This line is dividing into two parts and this line is also dividing into two equal parts. Again, can I say 2 times of Ix or 2 times of Iy will be equal to how much? Iz. So Ix or Iy will be how much? Ma square by 12. Correct? So which option? Option D. Now you will say you solved everything. I didn't want to solve, but I did it so that you can see it. But don't try to solve it in the exam. Try to recall the concept what we discussed. These kind of questions you should be able to solve in 5-10 seconds. Remember the fundamental what we discussed. So if you find the moment of inertia of a square about a diagonal or about a line which divides square into two equal parts, it's the same thing. That's what they're asking in the figure. There's a diagonal and a line which is dividing into two equal parts. So moment of inertia will be same, which is ma square by 12. Clear? Any doubt, students? Anyone? No? You guys are intelligent. You guys understand everything in the first attempt. Same thing you guys would have studied properly in grade 11. है ना? अभी picture would have been different. Most of you would have cleared JEE mains with very good rank. That's what I tell. Whenever a student comes to me in grade 11, I tell this thing that always focus on fundamental. Don't go hi-fi. I'm telling you, hi-fi people means very less people succeed in that. But if you take the fundamentals from starting till the end, till the second year, 12th, you will clear all the exams. And these things, what I explained just now, are the fundamentals. And that previous question, these all questions, what I do in maths and physics, these all are previous year JEE or NEET questions. So that you get the idea that what is the level. And after seeing most of the questions, very few are very difficult, very few. So this question is exactly same as the previous question. Can you guys find out the answer without solving? Tell me what is the answer, which option? We did it just now. Option D. We did it right, diagonal. What is the answer? D. Just now we discussed. Clear? Is the logic also clear? Why? Don't mug up that. But just remember that thing that about axis which is perpendicular. For rectangle. Remember for rectangle, then make it a square and then apply perpendicular axis theorem to divide into two equal parts. Okay. Now this same question was asked in JEE Advanced as a assertion reason. Okay. Because some of us mug up the formula, but they are smarter than us. Instead of giving the mass as m, they gave the mass as 2m. Okay. And still most of the students take the answer as ma square by 12. That's the reason I'm telling don't mug up. Remember the process. There was a very small twist. The student who wanted to notice noticed. The student who mugged up directly ticked D. Always read the question. Sometimes they change the radius here or the length. Here the side is what? A. They make it A by 2. So instead of A, what will you put there? A by 2. So do the substitution properly. That is the reason. Remembering the flow is important rather than just remembering the final expression. It is a right way to understand any topic. Okay, next problem. Okay. So there are three particles which are kept what? Along the vertex of a triangle. And you need to find the moment of inertia about this axis EX, which is perpendicular to EG. But this axis is in the plane of the figure. What is the meaning of that? That if you are drawing this figure in your notebook, this axis of rotation is also present in the notebook itself. That is the meaning of same plane. It's not like that this axis is perpendicular to this plane. Okay, so sometimes if they say perpendicular means if this is the plane of the figure, axis of rotation will be perpendicular. But they are telling it is in the same plane, means same plane, this plane. So side A, it is an equilateral triangle. Mass is also same. So what will be the moment of inertia of particle E?
So is it 25?
25. Okay, noted. Don't know the answer. I will check it. But what is the moment of inertia of particle E? Zero, because it is on the axis of rotation. Okay, so E ka zero. What is the distance of G? A. So what will be the moment of inertia of this? Ma square. Plus, what is the distance of E? A by 2. M A square by 4. Very good. So when you add, how much it is? 5 ma square by 4. And will be how much? 25? Correct. Very good. Very good, Aditi. Okay, you guys got why n will be 25? Because it is n by 20 ma square. So if you compare this with n by 20, so 5 by 4 will be how much? N by 20. Okay. N will be how much? Cross multiply 25. Right? See, Abhi, just now I told you. that if you take the fundamentals with you and you remember things, problem is that most of us forget. This is basically 2020 JE question. And you guys solved it. Most of you solved it within 2 steps. Okay, but now there is no point of talking about these things. Okay, your time is over. I just want you to, whatever time is left, give your best. Okay. Time is over doesn't mean that everything is over. You will have a new phase of life starting in college. You will do wonders in college. Okay. Just believe in yourself. Take this as a lesson that if you make your fundamentals strong, you will always do wonders. Things are not difficult. We make it as difficult by seeing everyone else, not us. We see others. That is the problem. Okay, done. Easy question. Chalo, let's move to the next question. So you guys have solved a lot of easy questions. Now let's take a challenge. है ना? MR square, MR square. I gave a lot of easy questions. Copy this question. This one you can mark as important. It is one of the best questions. Not difficult, but very good question of moment of inertia. Because here you can see that the density is not fixed. The mass density is changing. So you have to take the help of integration. You can't directly do MR square. You will not get the answer. MR square will help you when the mass is uniformly distributed. Okay. Here mass is not uniformly distributed. You can see the density is changing with position. For different values of x, mass density is changing. You can see it is depending on x. Let's do it. I will solve it. You guys just see here. So what is the basic formula for moment of inertia? Di will be equal to what? Dm into r square. Here it is x, so I am writing x. Di means small moment of inertia of a small particle of mass dm. Dm means a particle of mass this much, dm, small particle. And what is x? X is the distance from the origin. Or you can say x is the distance, perpendicular distance from the axis of rotation, whatever you choose. So I want to find total moment of inertia. So it will be what? Integration. That's why we use integration. Find total. Now what is linear mass density? Mass by length or mass by length? Anything? Anything? If I take a rod whose mass is m, length is l, this length is l. At a distance x, I'm taking a small element whose length is how much? Dx and mass is d. I have considered a small particle for a distance of x whose mass is dm and length is dx. So how will you find dm from here? So dm will be equal to how much? Lambda. Any problem, students? Anyone? So substitute lambda x square dx. So what is lambda? This value. Substitute. So lambda is this. In this, what is constant if you see? Lambda naught. So we'll take lambda naught outside the integration. So integration of 1 plus x by L into x square into dx. You want the moment of inertia for the whole rod. You will start from where? X equal to 0 to x equal to L. X equal to 0 to x equal to L. Now let's open the brackets. So it will be x square plus x cube by L dx. So
So is
integrate
it
it. What is the answer?
7 by 18?
7 by 18. I think it is correct. Let me check it. Just give me 1 minute. I'll just finish this integration. So substitute the values. What is the integration of x square? X cube by 3. What is the integration of x cube? X to the power 4 by 0 to L. Substitute. So put the upper limit. It will be L cube by 3 plus L to the power 4 by 4. So L and L will get cancelled. So this will become what? L cube by 4. And the final thing will be 0 when you put the lower limit. So take the LCM. What will be the LCM? 3 4s are 12. So 4 plus 3, 7. So 7 L cube by 12. So this is the moment of inertia. But are they asking moment of inertia? Check. No. Now there is one more step. There's one more step. They're asking mass. See mass, right? So the question is not over. Copy till here. Let me check the answer. I got one answer. 1 second, Kunal. I'm checking the answer.
So they are asking moment of inertia, right?
They're asking moment of inertia. Okay. Moment of inertia. I thought that mass. Yeah, they're asking moment of inertia. 1 second. Let me check the answer. What option you told? No? Option B.
Yes.
I think it is correct. Okay. All of you copy till here. So in the option anywhere lambda naught is there? No. Okay. You can see that anywhere there's no lambda naught. So how will you do that? How will you do it? If you see that, what is dm? Dm is lambda into dx. So what will be m equal to? Integration of that, correct? Dm is this, so m will be what? Integration of that. So what is lambda? This thing. Lambda naught you can take outside 1 plus x by L dx. Solve it. What is the integration of 1? X. What is the integration of x? X square by 2. You will integrate from where to where? Starting point to ending point. So this is lambda naught into L plus L square by 2L, which will be L by 2. So this is how much? 3L by 2 into, so 3L by 2 into lambda naught is M, correct? So what will be lambda naught equal to? 2M by 3L. So you can substitute it here. 2M by 3L. So 2M by 3L into 7L cubed by 12. So what can we cancel? L, this becomes L square. This is 2 6 are 12. So this becomes 7M L square by 18, which is option. Everything is not very easy. Yes, this was a good question. It will take time. So till here, I think most of us can manage, means finding the moment of inertia in terms of this. After that, when you see that there is no expression for lambda naught, most of us leave it. You have to think that how can you find lambda naught? By finding the total mass, because everything is in terms of mass. It means that you have to find the total mass. The total mass I can calculate from here and then. Okay, move to the next problem. Copy, quick. Just can just write the question number, no need to copy the question. If you want the PPT, I'll share the PPT in which all the questions are there. I already told you. You can just let me know, I'll share the PPT. But do write down the answers. Next problem. So before we discuss the next problem, all of you see on the board. What is the kinetic energy of a body which is rotating? Half I omega square. Okay. How do we write it? This is for rotational motion. How do we write it? By using half mv square. So m is inertia, I is moment of inertia, v is linear velocity, omega is angular velocity. So this is the kinetic energy of a body which is rotating, rotational. Now, if you remember, we discussed conservation of linear momentum. If an object doesn't experience any external force, its initial linear momentum and final linear momentum are same. In the same way, if net torque is zero, if net external torque is zero, angular momentum is conserved. There are two formulas for angular momentum. First formula is R cross mv. This is the first formula. And what is the other formula? L equals to I omega. These are the two formulas for angular momentum. So if there is no external torque on the system, we will say that the angular momentum is conserved. Any object which is rotating, it will have which momentum? Angular momentum. Now all of you read the question, we'll discuss. No problem. So a wheel is rotating freely with angular speed omega. The moment of inertia of the wheel is I, and the moment of inertia of the shaft is negligible. Another wheel of moment of inertia 3I, initially at rest, is suddenly coupled to the same shaft. The resultant fractional loss in the kinetic energy of the system. Let's solve it. Very simple question. What is the initial kinetic energy? Is the second wheel rotating? No. So what is the initial kinetic energy? Half I omega square. What will be the final? Half. So this time you have how many disks? Two, right? And both of them will move together with a common angular velocity, right? One disk is rotating and you put the other disk also on that. What will happen? Now both of them will rotate together with a particular angular velocity. So what will be the total moment of inertia? I plus 3I. And do I know the angular velocity? No, I don't know. I have to calculate. So how will you find the new angular velocity? By using conservation of angular momentum. So using conservation of angular momentum, what will you write? Initial angular momentum is how much? I omega plus second one is not moving, so 0. Second, now both of them will move together because one is placed above the other. So I plus 3I, how much? 4I with an angular velocity omega dash. So what is omega dash equal to? Omega by 4. Clear? Any doubt in applying this? So when you substitute here half into 4I, omega dash is omega by 4. So this will be omega square by 16. So half I omega square 16 and 4. This will be how much? 1 by 4. Correct? So what are they asking? What is the fractional loss? So what is the fractional loss? When you subtract it, how many times? 3 by 4 times. You can see that when you subtract, what time of loss is there? This is 1/4 of this, right? So what is the loss? How many times? 3/4. 3/4 means how much percentage? 75. So what is the answer? Clear? Don't do the calculation after this. Some of you do the calculation after this also. See here, it is 1 by 4. This is 1 times. That is the reason I separated the constant out. This final is 1/4 of the original. How much is lost? 3/4. Easy question. Yes, there is nothing difficult in this. So this is the kinetic energy of a body which is doing rotational motion, not rolling. Don't get confused. Rolling is different. This is only rotational. Rolling means rotational plus translational both, which is basically the motion of the wheel, okay, which moves forward as well as rotate. This is only rotational, not rolling. Done. Okay, let's discuss this. Again, this is a question of maximum 1 minute. Within 1 minute, you can solve. We have to use energy conservation. Energy conservation. Okay. All of you just see this thing. Just observe. Suppose this is ground. The rod is fixed like this. The rod is fixed. Okay. What is the length of the rod given? 1 meter. This angle is 30 degrees. So what will happen? It will basically fall like this. At this position, it is at rest. What energy does it have? Kinetic potential. It is basically at a particular height or inclination, right? Which energy it will have? Gravitational potential energy. The moment I release it, I say that boss, I am holding it. Let's assume I am holding. The moment I release, what will happen? The potential will keep on decreasing, and what will increase? Kinetic. So can we say energy conservation? Initial mechanical energy will be equal to final mechanical energy. Initial mechanical energy is what? Only potential, no kinetic. And final will be only kinetic and no potential. Because the moment it is about to hit the surface, on the flat surface, what is the height? Zero. The gravitation potential energy? Zero. But kinetic energy will be there because it will be hitting the surface with a particular velocity. Now answer this thing that it is fixed here. So what type of kinetic energy it will be? Half mv square or half I omega square? I omega square because it is rotating. Is it moving in the forward or backward direction? Is it having any linear velocity? No, it is rotating because it is fixed here. So rotating means rotational kinetic energy, which is half I omega square. Correct? So all of you write down conservation of mechanical energy. So what is the moment of inertia of a rod about one of its end?
1 by 3 ml square.
Correct. ml square by 3. Moment of inertia of a rod about one of its fixed edge is ml square by 3. Take. And moment of inertia of a rod about the axis passing through its center is ml square by 12. Okay. If you guys have still not seen my lecture, see it. I've explained everything there in detail. It means from A to Z. If you don't know anything about rotation, you will see those lectures, you'll understand everything. So potential initial, kinetic initial is 0. Final potential plus final kinetic. So potential is 0 when it hits the ground, half I omega square. And potential. What will we write potential energy as? mgh. What will be h? What will be its vertical height? What will be the vertical height? 1. Vertical height of this? 1. We did this in work power energy. Still you guys have confusion. No. No. None of you remember what will be the vertical height we'll take. We did this type of question in work power energy.
So 1 by 4.
1 by 4. How 1 by 4? L by 2 sine 30?
Yeah.
Good. We did this in work power energy that whenever you have a vertical object, we always take its height from its center of mass or center of gravity. So what is the center of gravity? Center of gravity will be here. This will be what? 1 or 1 by 2? 1 by 2. So you want the height. So this height will be how much? 1 by 2 times sine 30. So this will be L by 2 sine 30. Revise what we do in the class. These are the basics of work power energy. So whenever there is an object at a particular height, when you are calculating its potential energy, you will take the distance from its center of mass. Okay? That is the reason we are calculating from center of mass. Center of mass, this one is what? 1 by 2. This will be what? 1 by 2 sine 30. Basic trigonometry. So this will be what? mg. Sine 30 is 1 by 2. So this becomes how much? 1 by 4. Substitute mg by 4 equal to half ml square by 3 into omega square. What is asked here? Angular speed. Mass gets cancelled. L is 1, right? So omega square will be equal to 6g by 4. So 6g by 4, 60 by 4, 15. Omega square is 15. So omega is root 15. Anyone getting the value as 15? Is it coming 15? All clear? Any doubt in this? So this is the energy conservation in rotational motion. Any doubts? Ranvi, Raman,
No,
Saket, Manas.
no, sir.
So this pulley, what is the shape of this pulley if you see? This. What is the moment of inertia of this? mr square, right? So when released from rest, the bob starts falling vertically. Suppose I am keeping my hand here. The moment I remove my hand, what will happen? This bob will start falling down because of its own weight, and this will start rotating. Just understand what is happening here. When this bob starts moving down, has some velocity, so it will have what? Half mv square, correct? When this disk is rotating, what kinetic energy it will have? Rotational kinetic energy, which will be half I omega square. Is this thing clear to all of you? So when it has covered a distance of h, the angular speed of the wheel will be. So it is moving down also. Okay. So what is happening? It will have potential energy or not? Yes, it will have. So think of that. How can you apply conservation of mechanical energy? Because are you applying any external force on this? No. So it means initial mechanical energy will be same as final. So think, how will you solve this? I gave you the hint that what type of kinetic energy it will have. Half mv square for the bob, half I omega square for this wheel, because it will rotate. And because it is moving down, so it will gain what? Potential energy also. Kinetic energy will be same. No, kinetic energy will not be same. Both are two different type of object. They will have different velocity. And first of all, this will have linear velocity. This will have angular velocity. No, no idea. So if I apply conservation of mechanical energy, what will happen? mgh will be equal to how much? Half m v square plus half I omega square. Any problem in this? Any student? Conservation of mechanical energy. Is this thing clear to everyone? Anyone having doubt in this statement? Now you know everything. Substitute. So they're asking what angular velocity. So if you see here, what will be I? Because wheel is a disk, I will be what? What is the mass of the disk given? M only, smaller. mr square by 2. Write down that. And now see one more thing. V equal to omega r. So whenever there is a rolling without slipping, we write V equal to omega. And I think you guys know this, right? In circular motion, what is the relation between linear velocity and angular velocity? V equal to omega r. We can substitute that here. M, M, M will get cancelled. So this will be GH equals to half. V will be omega r plus half. M will get cancelled. Mr square by 2 into omega square. So you can take omega square common. So you can multiply by 2. 2GH equal to omega square I will take common. So this will be R square plus how much? R square by 2, no? Which will be omega square into 3R square by. So you can multiply. So it will be 4GH by 3R square equal to omega square. So omega will be equal to 2 by R into under root GH by 3. Any option? Any option matching? Yes, it is matching option A, I think. If you take this 4GH by 3, let's move to the next column. All of you have to write with me. That is the reason I told that read the lecture and come. Otherwise, I have to extend for 1 hour to finish this. After that, half an hour. You guys have to read the basics and come to the class so that you can copy down these things with me when I'm explaining. Done? Okay, calculation. I hope that it's clear. Sure, let's move to the thing. V equals to omega r. There is a relation between linear velocity and angular velocity that is discussed in circular motion also. So, are you guys comfortable with the energy conservation in rotational motion? These are the two questions I took. Next problem. Moment of inertia of a body about a given axis is 1.5 kg per meter square. Initially, the body is at rest. In order to produce a rotational kinetic energy of 1200, the angular acceleration 20 must be applied for how much time? So time is being asked. So once time is coming into picture, what are you thinking of? What should we apply? Equations of motion. So think of, I gave the hint. Solve kar bhai, solve. Don't talk. I will solve. Full All of you are dependent on me. I gave the hint, try it. See what is the information given. Kinetic energy is given, angular velocity is given. What is the power of physics? Seeing the lecture will give you the concept.
So is it 2?
Two. Okay, noted. I got one answer as
So is it 2?
two. Okay, noted. Two is the right answer. Very good. Simple question, hai yaar ye. Three steps. I gave the hint also. Three-step ka question. See here. See on the board. I got correct answers also from few of the students. I think Aditi and Kunal answered perfectly. See here. Kinetic energy is given. What is the formula for kinetic energy, Dhruv? Half omega square. So 1200 equal to half. Moment of inertia is 1.5. So omega square. So this will be how much? 2400 divided by 1.5. That is omega square. Correct? They're asking time. So if you remember, V is equal to U plus AT, right? So here V will become what? Omega. U will become omega naught. Linear acceleration will be angular acceleration. T will be T. Any problem? Anyone in this? How I wrote this from here to here? Linear will get replaced by angular. Angular, angular, angular. So this is 0. So omega is equal to 0 plus what is angular acceleration? 20t. Substitute this. So omega will be equal to what? Square root of this much, right? So this will be 24,000 by 15. It will get cancelled by what? 15. Will it get cancelled with 15? Yes. 15 ones are 15. 90. 15 6 are 90. 1600, right? 40. So 40 by 20. 2 seconds is the answer. Done. Right? Simple. But anything. After seeing the solution, physics is the easiest subject. Easiest. Okay? That's what I used to feel when I was in grade 11. How I used to study, I used to see the answer of every question after I solve, and I used to feel that it's not easy. Whenever I used to write exam, I used to get 1 marks, 2 marks. I'm talking about the advanced level paper. One question or two question I was able to solve. Then in the end, means towards October, I went for physics tuition. I was very lazy to take tuition. Laziest one. Because tuition, the place where I used to live was very interior area. That was Air Force campus. The Air Force campus used to be always outside the city. If you see Bangalore also, now Yelanka is a town. Correct, Jalali is a town. But when I came here in 1996, I was in third or fourth grade. The Yelanka was considered the outer part of the Bangalore. That was not the part. Okay. The same thing where I was living, my tuition was 16 kilometers away. I had to change bus 3 times. So I went for 2 days. After that, I stopped going to tuition. Huh? Then I took the tuition in grade 12. I went for demo class and then I told my dad I didn't like it. And I went to the same teacher again in October. So let's move on. So sometimes being lazy harm us going into the comfort zone. So I just wanted to. Huh? I teach maths also. I was not able to take LCM when I was in 6th, 7th grade. He's making sure that we don't miss Saket. I think Saket sent him today. Parinit, you guys download the admit card of Kcet? Where is the center for it? I think Kcet admit card. So two beads of mass m and negligible size are at the center of the rod. So if the beads are present at the center of rod only, what is R there? 0. So what will be their moment of inertia? 0. If I is 0, what will be angular momentum initially? I omega? So 0. Is it clear? These two beads are present at the center of the rod. Means if the rod is rotating with an angular velocity omega about an axis perpendicular to the rod and passing through its centers. If this is a rod, It is rotating about this axis. Okay. And those two particles are present here itself. So what is the distance of these two particles from the axis of rotation? Zero. Moment of inertia of a particle is what? mr square. The moment of inertia of these two particles will be zero. Angular momentum is I omega. So angular momentum will be also zero. Kinetic energy is half I omega square. So their rotational kinetic energy will be also zero. The beads are free to slide. So they will free to slide along the rod. The angular speed of the system when the beads reach the opposite ends. So this is the initial scenario. Finally, what is happening? One of the bead is here, other bead is here. That is the final situation. Why will they move apart? Centrifugal force. Why will they move towards the other end? Centrifugal force. That's what you feel when you sit in the car and they take sudden turn. You feel that you're going towards the door. Centrifugal. So that's what. So they will have, once it starts rotating with a high speed, they will have a tendency to separate towards the end. So the final situation is this, initial situation is this. Any external force on this? No. Will the conservation of linear momentum hold true? Yes. Not linear, angular. Initial angular momentum will be same as final. Tell me the answer. Find out the
Answer.
answer quickly. Yeah, you got the answer? Tell me.
Oh no, so I have a doubt.
Hmm.
Is angular acceleration and centripetal acceleration the same or different?
It's acceleration? No, no, no.
Angular.
They are different.
Okay.
Hmm. The answer. So initial angular momentum will be equal to final. Initially, what is the angular momentum of these two beads? Zero. So initially, who is rotating? Rod. So what is the moment of inertia of a rod about an axis passing through its center? I told it in the class. That is about one of its edge by
That was
12.
at 12.
12. Jago Mohan Pyare. Have you guys heard of this line? Okay. Don't sleep in the class. Concentrate. Huh? Who is Mohan? So you have not heard of that song then. Yeah. Whatever. It's if you have read Hindi or Sanskrit also in that we use this. Chalo, ठीक है. So tell me that initially what is the angular momentum of the bead? Zero because it is present at the axis of rotation itself. But the rod is rotating. Rod ka mass is m, length is l. What will be the moment of inertia of a rod? About the axis passing through its center, ml square by 12. If the same axis of rotation is here, then it is ml square by 3. That's what we use in one of the questions. So omega. Any problem? Now finally, what is my system? Finally, my system is rod plus these two beads, correct? It is in the end. So what will I write? ml square by 12. See this thing carefully. Plus, how many beads are there? 2. So 2 times of, what is the mass of each bead? M. And what is the distance of the bead from the center? L by 2. So what is the moment of inertia of a particle? mr square. So m into r square. Any problem? Why multiplied by 2? Because there are 2 beads. Do I know the angular velocity? No. So I will write that as omega dash. So solve it. Tell me what is omega dash. I think this is omega naught. It is given in the question omega. Solve it. Tell me the value. So this is ml square by 12 plus this will be how much? Ml square by 4. So this becomes ml square by 2, right? Omega dash. L square we can cancel from both the sides. So it will be m by 12 omega naught equals to m by 12 plus small m by 2 into omega dash. What is the LCM of 12 and 2? 12 itself. So it will be capital M plus 6m. Do we have any option for m plus 6m? Yes. I will not solve after that. No need to solve. Why will you solve? You can see, right, m plus 6m coming when you solve this. That m plus 6m will go in the denominator. Which option is there? That is the advantage of observing the options. You don't have to solve till the last step. I didn't solve till the last step. You guys can see that. I just solved the left hand side. I saw that because 12 and 12 will get cancelled on both the sides. So in the numerator on the right hand side, it is m plus 6m. That will move towards this side. It should be in which term? Denominator or numerator? M plus 6m in the denominator. Clear? So we covered conservation of mechanical energy also, conservation of angular momentum also, moment of inertia also. Now what is left? Torque. Torque, equilibrium and rolling. Okay. So equilibrium questions are very simple. Okay. So I will just take one question on that. What I will give homework in that you can solve. Huh? If you have done Newton's law of motion properly, equilibrium is very simple. Okay. So equilibrium of the body. This is the thing. So I will quickly explain this thing here. All of you just see on the board. Just give me 1 minute to explain, then we will solve this question. See, if there is an object here, I am applying a force F1 and a force F2. And this object is present on a support. This is called fulcrum. Fulcrum. Okay, on which it is resting. So is there any contact with this fulcrum or support? Yes. Whenever there is a contact, which force is there? Normal. Correct? So these are the force acting on what? This thing. So what I'm asking is, suppose this distance is x, this distance is d minus x. Question is, at what distance F1 should be applied so that system is in equilibrium? So that system is in equilibrium. Now, what is the meaning of equilibrium? You only think that if you push it in the down direction, forget about this force and this force, forget about that. If you push in the downward direction, what is the tendency of this object? To rotate in which direction? Like this. This which direction? Anti-clockwise. So if you want any object to be in equilibrium, it means the net translatory force should be zero and net rotational force should be zero. And what is the rotational force called? Torque. Okay, rotational force is called torque. For any object to be in equilibrium, what we say that net translatory force should be zero and net rotational force, which is basically torque, should be zero. Okay, this is the condition for any object to be in equilibrium. In Newton's law of motion, the object was not having any tendency to rotate. So that's why we are not considering this condition. We are focusing only on this thing, net force equal to zero. If you see here, what will you write first equation? N equal to F1 plus F2. So this is the condition for what? Net translatory force equal to zero. What force equal to downward? Now, we are assuming that I am applying torque about point O. About point O. So you forget about these two forces. Ignore this. Just think that if I apply a force in the downward direction on this object, where will it rotate about point O? Anti-clockwise or clockwise? Anti-clockwise, common sense. Whenever you do this, I'm repeating again, you focus only on that force, ignore all the other forces. Think that they don't exist. Similarly, if you see F2, if I apply a force F2 on this end of the rod, about point O, it will rotate in which direction? Clockwise or anti-clockwise? Clockwise. Okay? There is no physics involved in this. Now, if I pass the force to the point itself, will it rotate? No, do not rotate. Common sense hai, yaar. Physics, forget physics here. I want object to rotate about point O and I am applying the force on the point O itself. Will it rotate or move up? So what will be the torque due to N about O? 0. So how many torques are there? One creating an anti-clockwise torque, F2 creating a clockwise torque. Both should be equal and opposite so that object will be in equilibrium. Is this much clear? This concept you have to apply in equilibrium of body. That's it. Nothing else. Nothing else. So I will write torque about point O. So F1, what is the formula for torque? Force into perpendicular distance. Force, you have studied this in grade 12th also. Torque due to a dipole in electric field. Force into perpendicular distance. So force, what is the perpendicular distance? X. So this is anti-clockwise. That should be equal to clockwise. So force into perpendicular distance. All clear? We need to find what? X here. So bring all the x term together. F1x plus F2x equal to what? F2d. Right? Take x common. X into F1 plus F2 will be equal to how much? F2d. X will be F2 by F1 plus F2 into. All clear? F1, F2 should be given in the question. So this is also a numerical. They can ask you calculate n. N will be what? F1 plus F. So we are finding the torque about which point? O. Yes, bacha, are you done? Any questions? Anyone? If you have done copying this, solve that problem. Solve the question given on the board. मेरे क्लास के टाइमिंग को सिलेबस नहीं खत्म हो रहा है मेरा. I'm trying to extend and they want to do this thing. Now the entrance has become better. Have you seen? बहुत broad कर दिया. Now you can आराम से walk also. Then you can stand and बहुत चौड़ा कर दिया. Means from there till here, it's that big. So no one. Chalo, let's discuss it. Try to solve it. It's basically similar as what we have done just now. So what are the forces? This force will be how much? 2 mg. 2 mg. And any other 1 meter long rod. The rod is of mass m. So at the center, there will be weight of the rod. So this mg is the weight of the rod. So this mg is the weight of the rod. It will act at the center. Okay. We have hang 2m, so there will be a weight of 2 mg. Any problem? Now it is tied to the string. What forces will be in the string? Tension. So there will be tension. Tension is always away from the object. So TB and this will be TA. Any force missing? No. Okay. Where will be normal, right? Where is normal? Where is the contact? Normal force is there when there is a contact. For it. Okay. Okay. Now we need to find what? Tension in the string. First thing, what will you write? The translatory equilibrium. So TA plus TB will be how much? 3 mg, right? First equation. This is for translatory equilibrium. Upward force equal to downward force. Now we have to find out what torque, net torque. All of you listen to me here that we need to choose the point carefully. About which point we should find the torque. You can choose any point. Any point. Answer will be same until unless you do any mistake. Okay? Method will not be wrong. Method is correct that you can choose any point to take the torque. I need TA or TB? TA. I will find the torque about this point. This point. What is the advantage of that? How many variables will be there? Only one. Because if I choose this point to apply the torque equation, what will be the torque due to TB? Zero. Why? Because the force is passing through the point itself. That's what I told you. Choose the point smartly so that you reduce the number of variables. The moment they would have asked, find TB, then I will take the torque about A. So if you pass the force through the point itself, the torque will be zero, because what is the formula for torque? Force into perpendicular distance. If you're passing the force from the point itself, what will be the perpendicular distance? Zero. Torque will be zero. Make a note of these things. So I am applying torque about which point? B. So what will be the torque due to A? Force into perpendicular distance. What is the distance? 1 meter. So TA into 1 meter. So this TA ka torque will be in which direction? Correct? Yes or no? You are pulling it in the upward direction, right? It will move in which direction? Clockwise. And these two things are pulling in the downward direction. So torque will be which direction? Anti-clockwise. Clear? So mg, what is the distance of mg from point B? 50 centimeters. 50 centimeter means how many meters? 50 centimeter. How many meters? 0.5 plus 2 mg. What is the distance of 2 mg from here? 25 centimeter. 25 centimeter means 0.25. So solve it. Mg, so 2 into 0.25, 0.5. 0.5 mg plus 0.5 mg is how much? Mg. What is the answer? TB will be how much? TA plus TB is 3 mg. So TB will be how much? 2 mg. Clear? Any problem? You guys can manage these type of questions aram se. Translatory equilibrium and rotational equilibrium. In every problem, this type of situation will be applicable. Okay, chalo, let's move ahead. Copied? Any doubts? Anyone? Next problem. Copy the question. Say R is given here. We need to find what? Angular momentum. What is the formula for angular momentum in terms of position? R cross mv. R cross mv. R is given. What is missing here? V. How do you find velocity from position? Differentiate. How do you find velocity? Dx by dt, dr by dt. So how will I find velocity? By differentiating it. Do it. Question is solved. Find velocity. Question is solved by differentiating it. Very easy question. That's written in a fancy way, but question is very simple, straightforward. So angular momentum in terms of position is R cross mv. Mass is scalar or vector? So what we will write? M into R cross V. Can I write this? Okay. R is given to me at t equal 2 second. What will be R? If t equal R at t equal to 2. 2 to the 4. 4 3 is 12. So this is your position. Any problem? I need to find velocity. How will you find velocity? Differentiate it. So velocity will be dr by dt. Differentiate. 2t will be 2I cap minus this will be what? 6t j cap. Any problem in differentiation? Put t as 2. So velocity at t equal to 2 will be how much? 2I minus 6 to the 12. Done. All of you know vector product? Everyone? Do the vector product. Tell me the answer. Find out the answer quickly. What's the answer? Not much time for dot product. Sorry, cross product. Minus 24. We forgot to this 2I. Minus 48 k cap. K cap? Getting everyone? Anyone who don't know the cross product? Anyone? I'll solve it. Minus 48 k cap. Simple question. Can you see that? Means the way they ask the question, when you see the question for the first time, you'll feel that something new has been asked. But the moment you structure the thing properly, it is one of the simplest questions. Or you can see this is a question of cross product, not rotational motion. All of you see a few things. We'll discuss rolling. I'll just quickly explain that rolling part. It will take 2 minutes for me to explain. See, there is something called rolling. Rolling means the combination of translate. You guys can copy with me itself. Translatory plus rotational motion. Translatory plus rotational motion. What is the simplest example, real life example? The motion of the wheel of the car, bike, cycle. So basically, the example is motion of the wheel, okay, of a vehicle, of a car, you can say, car, bike, cycle. So the way the wheel moves, so what happens to the wheel? Does it keep on rotating at the same place or it moves forward also? Forward. So if you draw a wheel here, so this wheel have a translatory motion, and who's responsible for translatory motion? Velocity of the center of mass. And it has an ability to rotate also. Okay, it has the ability to rotate also. So when both the motion is happening together, then we say that it is what type of motion? Rolling. Now in rolling, there are two things. The first thing is pure rolling. So in pure rolling, what we say that velocity of center of mass is always equal to omega r. Okay? These two velocities will be same. But if it is not pure rolling, which is called rolling with slipping, rolling with slipping. Let me give a simple example. Have you guys seen in horror movies what happens? Suddenly, the ghost is behind you. The car will get stuck in some slushy or muddy place, and you're giving the accelerator, but the tire is keep on rotating at the same place. The tire is not moving ahead. Tire is doing more rotational motion as compared to translatory motion. Now, one person will say that you go out and push. Moment you go out and push, after that you don't exist. Okay, after some time, Annabelle will take you away. So, what I'm telling here is rolling with slipping means in that also two cases are there. First, the case where rotational motion will dominate the translatory motion. That is the example, the tire getting stuck at one place and you're giving accelerator, but the tire is moving ahead a bit, but again coming back. It is rotating more. That's why we say that pushing. When you push or you provide the external force, you support the translatory motion so that the tire comes out of that, whatever you can say, the wherever it is getting stuck. Now, the second case is when you apply sudden brakes. Have you seen those things in the movies? Tokyo Drift or Fast and Furious, any car racing movies. When they apply sudden brake, what happens? The car drifts. There, the car is doing more translatory motion rather than rotational. So, these two cases are called rolling with slipping. In one, rotational motion will be more as compared to translatory. In the second one, translatory motion will be more than rotational. So two cases are there. So first case is when VCM is greater than omega r. So translatory component is more than rotational. So this is called forward slipping. The second case in this will be just ulta. Omega r will be more. So this is basically called backward slipping. Any problem? All clear? This much if you have understood, you have understood pure rolling. Okay? Understand that rolling doesn't mean pure rolling. If I just say rolling, it can be anything. But the moment they say pure rolling means rolling is happening without any slipping. There is no slipping there. Pure means the translatory and rotational motion are happening in the same proportion. That's why both of them are equal. Anyone exceeds means slipping will happen either forward or backward. Nothing to mug up here. That's why I give the examples. If you remember the example, you'll never get confused in rolling. Written? Any questions? Anyone? Now, there are few formulas. There is a derivation also for that, but we don't have that much time that we do derivation. You have to remember the formula because every time you cannot do the derivation. But I have taken one question where we will solve the question without using the formula. There I will show you in a rolling motion how do we apply conservation of mechanical energy. Okay? If you get time in your grade 11 NCRT, when you open this chapter, system of particle, the last example of the chapter in the blue box. Example, there is a question when multiple objects are dropped from an inclined plane. They're asking which one will hit the ground with the highest velocity. Do solve that question in your NCRT grade 11 last example. Very good problem, very nice problem. Solve it after the class. So there they have done the derivation. I'm writing the formula directly. So velocity, this V is the velocity of an object which is doing pure rolling. Velocity of an object doing pure rolling on an inclined plane. So V is equal to square root of 2gh divided by 1 plus k square by r square. Okay. Suppose if we have an inclined plane, the height is h, the object is dropped from here. When it reaches here, what will be the velocity? This under root of 2gh. So if you see that, what is the extra term in this denominator? Under root 2gh, so you have learned, right? In motion under gravity also. If you drop an object, what is the velocity with which it hits the ground? Under root 2gh. By using third equation of motion. The extra term is 1 plus k square by r square. Now, what is k in this? Anyone knows what is k called? Radius of gyration. K is called radius of gyration. Okay, what is the meaning of radius of gyration? This is not gyration. Gyration. If you can understand here, I'm explaining. Whoever has doubt in this. Suppose if there is a ring or disc. This is a disc of a radius r and mass m. If this disc is rotating, what is the moment of inertia of the disc? mr square by 2. Okay. Replace this disc with a point mass of same mass. Mass will be same. Replace this object with a point mass. Mass m. I replace this disc of mass m with a point mass m. So they say that at what distance it should be kept so that the moment of inertia of this and disc is same. At what distance it should be kept so that the moment of inertia of this and this disc should be equal. That distance is called radius of gyration. So what will be the moment of inertia of this? Mk square. And what is the moment of inertia of this? Mr square by 2. So what will be k equal to here? R by root. This is called radius of gyration. I'm repeating the statement again. You replace the object with a point mass, same mass at a distance, such that the moment of inertia of this should be same as the moment of inertia of the object. Equate both, get k. So what is radius of gyration for a disk? R by root. All clear? You should be able to find the radius of gyration of all the objects. What is the moment of inertia of a sphere, solid sphere? Moment of inertia of a solid sphere? 2 by 5 mr square. Why you guys have not revised? When I told to revise, still if you guys are not revising, you are digging a grave for you. After few 3-4 weeks, you will think कि क्या हो रहा है? Revise. I told to revise basics. I'm reminding you guys again, when I tell something to revise, do revise and come because I select the question in that way only. I see full silence in the class except 1 or 2 students, no one answers. I don't know what you guys are doing. Okay. So what is the velocity of an object which is rolling down an inclined plane of a height h? 2gh divided by 1 plus k square by r square. All of you are clear what is k? So if you read the question, a solid sphere. is climbing with a translatory velocity v, if it is to climb the inclined surface without slipping means we are talking about pure rolling, then minimum velocity. So this is the formula. So for sphere, solid sphere, what is moment of inertia? It will be equal to how much? Mk square. So what will be k square by r square? K square by r square will be 2 by 5. Substitute. This will be answer. Clear? Same type of question they ask. If a sphere is dropped, a cylinder is dropped, a disc is dropped, okay? Which of the object will reach the surface at maximum speed? You will find the speed. For finding the speed, what will you calculate? K square by r square for all the objects. Okay? So whoever has highest k square by r square, denominator will be highest, velocity will be least. One more question they ask. What is the time taken? Listen to me carefully here. They will ask you which one will hit the ground at what time. So for calculating time, which equation of motion will you use? First, which is V equal to U plus AT. If they are dropped, what will be initial velocity? 0. VU already calculated. So T will be what? V by A. VU already calculated. What is left? A. How to calculate A? See here. Acceleration of a body doing pure rolling is g sine theta divided by, anyone knows the formula? G sine theta divided by 1 plus, no one? I divided by mr square. This is the acceleration of a body doing pure rolling on an inclined plane. Theta is the inclination angle. So g sine theta divided by 1 plus I by mr square. I is the moment of inertia. So can you calculate acceleration for any object? If they say disk, you will put the moment of inertia of disk, you will get acceleration. Substitute here, you will get time. I told you all the type of question what they ask. Velocity they will ask, this formula, acceleration this, time, first equation of motion. Any problem, Achapati? Anyone in the class? Clear? Check. Last thing, I'll just take 1 more minute. So the question what I asked you guys to do, NCRT, grade level NCRT, the last example. And these kind of questions you will find in the exercise also. Just pick 2, 3 questions and solve. All the things depend on this formula and this formula. That's it. Did I explain the last thing? Any object which is doing rotational motion plus translatory motion will have what kinetic energy? Both. Will have both. So what will you write? Half mv square plus half I omega square. So this is the kinetic energy of a body doing pure rolling. But for pure rolling, VCM is equal to how much? Omega R. Okay. So what will you write VCM as? Omega R. Or you can write omega as V by R. Okay, so remember this. Sometimes what happens, you start looking out, sir, V is not given in the question, but they are telling it is pure rolling. So VCM will be equal to omega R and omega will be given. So read the question properly. Substitute VCM as what here? Omega R and then move ahead. Or if V is given, omega is not given, you will write omega as V by R. Okay. So this is the end of this chapter. I hope that we covered all type of question. But the thing what I asked you guys to read, do. Okay. I will take 1 more question. I think you guys have bio class. I will not extend. I wanted to do 1 more question. That question I will do in the next class, which is basically energy conservation in pure rolling. Only 1 question is there. Okay. So for the next physics class, write down which topic we are going to do. Fluid mechanics. Fluid mechanics. Fluid mechanics is the next topic in physics, and in maths it is parabola and ellipse. So read the fundamentals and come. If you need my lecture, you can ping me. I'll put the lecture in the group so that you can see and come those lectures in the class. Chalo, bye guys, take care. See you in the next session.